GameDev journey. Right everyone, today we're going to be making Flappy Bird. Now we're going to focus on the gameplay over here. Flappy Bird, as I'm sure you know, is an arcade style game which the player controls the bird Fabi, which moves persistently to the right. Now it's not actually the bird that's moving to the right, it's only going up and down. It's actually the ground which is moving to the left, which gives you the illusion of perpetual motion. Now you have to navigate Fabi through these pairs of pipes that have these equally sized gaps placed at random heights. If you don't press the flap key or the spacebar or click the mouse, Fabi's automatically going to fall. He's only going to go up when you tap on the screen or press the action key. Now each successful pass through the pair of pipes gives you a point. Colliding with the pipe or the ground ends the game. Now, during the game over screen, you get awarded a bronze medal if you reach 10 points, silver for 20, gold for 30, and platinum for 40 points. So with that in mind, let's go ahead and start a new project. So I'm using Godot version 4.51 stable. I'm going to create a new project here. We'll call it Flappy Bird, and I'm going to use the / renderer. I'm just going to change my path here to my Godot project and go ahead and create it right there. Now, one of the first things you're going to want to do is drag all the assets, which you can find on the GitHub or in my Google Drive link in the description below, into your resources folder here. And here we have all the audio, all the sprites, and all the fonts and things that we're going to be using for this tutorial. So let's go ahead and set up the project. Now let's go to project settings. Let's find window under display. Let's change the size to something that is mobile friendly, 288 by 512. So we get a kind of a portrait view. Let's set the stretch mode here to viewport, and I think that should be enough. While we're here, let's go to the input map and set up our action key. Let's add an action. I'm going to call the action flap for when Fabi flaps his wings, and let's click on the little plus here and set the action key to spacebar or left mouse. I think we have to actually do it separately, yes. So let's click again and press the spacebar. So now we've got left mouse or space as the flap action. Then let's just go back to general over here, and let's go to the textures for rendering, and let's set it to nearest so that we get that crisp pixel art. And I think that's all the project settings we need to do. So now you can close. Let's switch to the 2D view. And one of the first things I'm going to do is set up something called a signal bus. Now that is basically a global listener for signals, because we're going to have a couple of signals that come through in this game. We need to know when the game starts, we need to know when the game ends, and we need to know when to update the score. Those are the three primary signals that we're going to receive. So I'm going to make a new folder here called scripts. And in scripts, I'm going to right click and make a new script called signalbus.gd. I create it, and we can now go ahead and edit it. Here we go. So it extends node. It's just a plain old node, and we're going to create our three global signals. So we're going to say signal, and we're going to call it game started. We're going to have another one called score updated for when the score updates, and we need to know the new score. So let's call it new score, and that's an integer. And we're going to have another signal for when the game ends. I'm going to call it bird crashed. So the bird has crashed with the ground, crashed with a pipe, that's the end. So those are our signals. Now we are going to register this script as what they used to call an auto load, which means it auto loads when your project starts and it's available to every other script or scene in the project. They've now changed the name to a global. So let's make this an auto load or a global, and I'll tell you more about what that is in a second. So you're going to go to project, let's just save it. So Control S, then it's project settings, globals over here. We're going to search for it in our scripts. There it is, signal bus. Open it, and you got to click on add. Now there it is, signal bus is a script. It's a global variable now. Now it's available throughout the project. So what is this thing called an auto load? Some people call it a singleton because there's only going to be one of these signal buses. Godot has now gone and called it a global. So this thing is a script or a scene or a node that Godot loads automatically when the game starts. And crucially, it never dies. It never goes away. It's a globally accessible node that persists for the entire duration of the game. We use it for two main things: data persistence, so saving information like high scores, which actually we should go and do. These are things that shouldn't disappear when the level restarts. We also use it for global communication. These are our signals here. It allows distant objects like the pipe, like the user interface, to talk to each other without being directly connected. So let's now go ahead and make the high score, because that's actually something we should do. So let's create a constant for the high score. So let's say const. This is going to be the file path because we're going to save the high score to a file. So let's call it save file path, and let's make it equal to the user / and let's just call it high score.save or .data or something like that. Now this user is a default path on Windows. I can't remember exactly what it is. You can look it up, but there's a user folder in Windows, and whoever the default or the current user is, it's going to save it in that folder. You can Google it and look up where is the user folder on Windows, Mac, Linux, whatever you're using. Anyway, this is where we're going to save our score. If you want to find it in your res folder, you could just change this to res. Then your high score is going to be saved here in the actual script, and we can do that for now, so you can see that it's there. You can always change it back to user later if you want. Once you export your game, you need it to be the user folder. That's the only safe place to save. All right. Now, since this script is global, it can also obviously handle the score and the high score. So let's add variables for both of these. So let's have var score. It'll be an integer, and let's set it to 0. And now that's our current score, or our round score. And let's have var high score. It'll also be an int, and we'll also set it to 0 to start. Now, in the ready function, we're going to load the high score. So let's create that function ready. Okay, and we're going to call load high score. Now that doesn't exist yet. We need to go and make it. So let's make that. So let's just change this. I spelled it wrong over here. It should be load. Okay, so let's make this load high score function. So function load high score, and it's not going to return anything, so it is void. And this is how it works. First thing we should do is check if a save file exists. So I'll put a little comment here and I'll say check if file exists, and we'll say if. Now if we go file access dot file exists, what's the name of the file? Well, it's the save file path, whatever we called it, that's our constant, right? Now if it does exist, let's open the file in read mode. So let's say now open in read. Okay, you can say mode. Right, so now we're going to create a file variable. So var file is equal to file access dot open. What's the name of the file? Well, it's our save file path. And what mode do we want? We want file access dot read, open in read mode. Now that'll then go and open the file in read mode. So we can do another check here. We can say if we've got a file to read, then we can say the high score is going to be equal to file dot get, and we want var get the variable, and it'll go and fetch that score. Otherwise we're just going to set high score to 0. So high score is going to be 0. So that's our load high score function, which will run as soon as this auto load is ready. It's going to load it. Now we might also, of course, want to save our high score. So let's create that function now. So we're going to say function save high score. It will just save, so it's not returning anything. It's void. So first of all, let's open the file, our file path, in write mode this time. So we can make a little comment for ourselves here. Open the file in write mode. So we're going to create our file variable again. Var file equals file access, and it's going to be .open, and the path is our save file path, and the mode is going to be file access dot write. Then again, if the file exists, we'll go ahead and store the variable. So we'll say file dot store var, and we want to store the high score. So we'll just send it across to the file, and that should do for saving the high score. So we've got loading, saving. In our ready function, as soon as this signal bus loads, it's going to load the high score, and if that high score is 0 because no games have been played, it will be 0. So what we need to do still is check to see if the current round score is higher than the high score, and if it is, then the current round score becomes the high score. This is a common array algorithm called finding the maximum. So let's go ahead and do that. Let's do a check high score function. So function check high score, and it's also void, and we'll say if the current score is greater than the high score, then the high score is equal to the current score, and we should save it. So let's save the high score. Okay, so that's for checking the scores. What else do we need to do? Well, we need to add a point. We need to add a score. When the actual Flappy Bird passes through the pipes without bumping into them, that's a point. We need to add a point to the score. So let's create a function to add a point. Function add point. All it does is add a point, so it's void, and we'll just increase the score by 1. And now we're going to emit our signal, our score updated signal. So score updated dot emit, and we can send through the new score, because if you scroll up and look, our score updated signal can actually receive the new score and update it. So now that will add a point. What else? We should reset the score to 0 and then tell the signal bus that we've done that. So let's create a function to reset the score. Function reset score, and it's void. And all we're doing here is saying score equals 0, and then emit our score updated signal with the updated score, which is 0. So this is resetting scores when I forgot the emit here. This is resetting scores after each crash. So you're flying along, your score is 5, you hit a pipe, you crash, you start again from 0. And I think that is about it for our signal bus. So now we can go ahead and get the scrolling background working, or at least the illusion of a scrolling background working. Let's save our signal bus, and let's go ahead and create our first scene. So we're going to make a new scene. So I'm just going to click on 2D scene. We've got a node 2D here as the root. This is going to be our main scene, so we may as well call it main. And we can zoom in here. This is our play area. Let's get the background going. So we'll add a new node. Let's search for a texture rect. There it is. It's just going to be a rectangle with a texture, with a background texture in it. Let's call this background. So background. Let's find our background day texture. So it is in sprites. There's background day, so I'm just going to drag it along to there. And now we've got our texture. That's our background. So we can actually match the minimum size here, although I think it pretty much has done it. You can expand layout, and we can set it to our 288 by 512 minimum size, just to be sure that it always takes up the full rectangle. So that is our background. Now let's do the infinite scrolling. So let's save this scene, our main scene. Let's make a new folder here called scenes. And inside scenes, we save our main scene. There we go. Now let's make a new scene for our ground, our scrolling ground. So I'm going to click on the plus there, new scene. We can have a node 2D again as the root. Let's rename it to scrolling ground. Okay. Let's add an area 2D so we can detect when the bird hits the ground. There as the root, our area 2D. Let's call it ground 1, because we're going to have 2 of these, because they're going to change places infinitely to make it look like the ground is scrolling. So let's add a sprite as a child of this. So let's search for sprite. Sprite, there it is, sprite 2D. Okay, and let's rename this to sprite 1. And let's set the texture to our base. Here's the base. So I'm going to set the texture to the base over there. Okay, and there you can see it. Okay. Let's add a collision shape node as a child of sprite 1. So, or actually of a child of ground. So let's go ahead and add a collision shape. There's collision shape 2D. It's added. And let's have a new rectangle. So let's go to the shape and let's make a new rectangle shape. And you can fit it to match exactly. or you can go and actually double click base, and we can see it's 336 by 112 over here. So we can go back to our collision shape, just expand the rectangle, and we can make it 336. There you get the length right, and let's make it about 64 high, half that height. And we want to actually move it up to the top. It doesn't have to be the full thing. I guess we could. Yeah, let's just cover it. Okay, we've covered the whole thing. Right, so let's now duplicate our ground 1, and we'll get a second ground 2. So Control D to duplicate, and now we've got ground 2. I want to rename this to Sprite 2, so we don't get confused. And now let's move ground 2 to the end of ground 1. So if I click on ground 2 and I click on move, let's go across till we get to the end. And I think it's about there. Let's zoom right in. I don't want to leave any seams. There, perfect. Okay, so we now have two grounds next to each other like that. And let's just check the position. Yeah, 336. That's perfect, because we had a look earlier and we saw that the size of the sprite was, or the X dimension was 336 pixels. So we're exactly at the end. So now we're going to add a new script to this rolling ground to make these continuously swap positions, because these two squares are going to move to the left, and once this square reaches the end, we're going to move it back to the right of this square, and then this square will keep going. Once it reaches the end, it moves to the back of this square, and you just get this conveyor belt action happening, which gives us the illusion of the scrolling. So let's save our scene, scrolling ground. Let's click on scrolling ground and let's add a script. So we'll put it in scripts, we'll call it scrolling ground, and we'll go ahead and create it. I'm going to maximize, and now let's see how this is going to work. We're going to need an export variable for the scroll speed in case we're not happy with the, so we can play around with it in the editor and adjust it. So I'm going to minimize this for a second, because I'm going to go ahead and because we're going to need two ready variables as well. So I'm just going to go ahead and grab the two nodes we need. So if you drag ground and then hold control as you release it over here, it creates the onReady for you. So I'm going to drag ground, then hold control and release. Now I've got my two onReady variables there without having to type. And we'll also need our export variable that I just mentioned. So let's create that. So add export var speed. This is the ground speed. It's a float, and we can make it equal to -200. Okay, so that can be adjusted in the editor, how fast the ground moves. Remember, it's a negative value because the ground is moving to the left. Okay, so now we need the width of our texture. So I'm going to say var texture width, and that's a float. We know it's 336, but we'll just set it to 0 to start with, and we'll probably let the computer calculate how wide it should be. Right, because that texture width is how far it needs to move left before we swap it, and we know it's 336 pixels, but we'll let the computer work out the details for us. Now what we need to do is get those calculations, let the computer work out the distance there in the ready function as soon as this node loads. So let's create the ready function, function_ready. Let's get the width of the image. Okay, let's make a little note for ourselves here. Get image width, this is the texture width, whatever you want to call it. So we'll say var sprite, and it's a sprite 2D, and it's going to be equal to our ground, so we can say dollar ground 1, and it's our sprite 1. Yes, there it is, sprite 1. So now we can say our texture width is going to be equal to sprite dot texture dot get width. And in case it's been scaled, we should multiply it by sprite dot scale dot x. So if we ever resize our screen size and we resize our textures to match, this will still work. Okay, now we need to make sure that ground 2 starts exactly next to ground 1. So let's say move ground 2 to start of ground 1. So we're going to say ground 2 dot position dot x is going to be equal to ground 1. Yeah, I made a mistake here. Ground 2 dot position dot x is going to be equal to ground 1 dot position dot x plus the texture width. That'll make sure that they are perfectly next to each other, just as we have them in our setup at the moment. Okay, then these ground pieces need to constantly move, and so that's got to happen in a loop. Our process function is a loop, and so we can put them in there, put them in the process function. So let's say move both pieces to the left, move both pieces to the left. So we're going to say ground 1 dot position dot x plus equals speed, that's the ground speed times delta, and then we're going to say ground 2 dot position dot x plus equals speed times delta. That should move them across. Now we need to reposition them once they move off screen. Okay, so let's check ground 1. So let's say if ground 1 dot position dot x is less than the negative texture width, that means it's moved the complete length of our texture, then we're going to say ground 1 dot position dot x is going to be plus equal to 2 times the texture width, because it's got to move 2 blocks over itself and the length of the second block, so it can be on the right hand side of the second block. Okay, now we can do the check for ground 2. So now we can say check ground 2, and it's basically going to be exactly the same check. So let's just copy this, paste it, and this is going to be if ground 2's position, if it's moved the entire texture width, then ground 2's position is going to be equal to 2 times the texture width, so it moves to the right. So let's save this and let's test it. We should see them moving. Yeah, and there it goes across and then resets. See that? Let's just full screen this. How can I? There, we can see it full screen. Okay, that's not a great way to visualize this, so let's instance it in our main scene and see how it looks. So let's just go to main and just go to 2D view here. And let's just go out of that. Okay, and let's click on the little chain here to add an instance. Let's choose scrolling ground, and we're going to put it at the bottom here. So let's just move it down to the bottom and move it across. So we want it there. And let's now run this. This is going to be our main scene. So let's select it as the current main scene and see what it looks like. And there you go. You get this seamless scrolling. So it looks like the ground is moving because we've got this endless ground here. Perfect. Okay, that's working nicely. Right, so now what else do we need to do here? Okay, well, let's go in our scrolling ground. We've got this area 2D as the ground. So when the bird enters this area, that means it's crashed into the ground. So we should emit a signal. And we've got our signal, our bird crashed signal. It's living in our signal bus. So we should shout to the signal bus that the bird crashed. So let's click on ground 1, click on node, click on body entered, connect it to our code over here. And let's say replace this here with, well, we can do a check. We can say if the body dot name equals bird. So we're going to have to remember now to name our class, or name our bird scene. The script, we should give a class name bird, and then this check will happen. So let's remember to do that. So we're going to say if body name is bird, then we're going to connect to the signal bus, and because it's global, you can actually find it here. Signal bus, and we're going to connect, or we're going to emit the crashed signal. So we're going to say signal bus dot, and it was called bird crashed dot emit. The birds hit the ground, we've got to emit the crash signal. And we can then actually, the game stops at that point and has to reset. So we should actually stop the ground from scrolling along. So we should make some kind of a stop function. So let's say we stop the ground, and the bird should also stop. So in the body that collided, we'll also call some kind of stop function. Okay, so obviously stop doesn't exist. We're going to have to go and create stop. So all we do is set speed to 0. So let's create the stop function. Function stop, it's void, and all we do is set speed to 0, and that will stop the ground scrolling. Okay, we should actually connect ground 2 to the same function. So we go to ground 2, we go to body entered. This time we're going to go and pick, and I'm going to choose ground 1. So they both call the same function. I'm going to say OK and connect. So ground 1 and ground 2, if the bird hits either of them, it's going to run this function here. Okay, now let's go and work on the bird here, because we need a bird to crash into the ground. So let's make a new scene, and that scene is going to be our player, but we'll call it bird. Okay, so let's make sure we save everything we've done so far. Let's make a new scene, and this time we're going to use a character body 2D. So create, let's rename our character body bird. This is our bird, and we're going to need an animated sprite and a collision shape. So let's add an animated sprite 2D, and let's add a collision shape again 2D. Okay, now on the animated sprite, create new sprite frames over here, expand them Here we go. Let's rename this default animation to flap, because that's what he's doing, he's flapping. And let's go find, I'm going to choose the yellow bird, and we've got a down flap, a middle flap, and an up flap. So let's connect these, let's drag them in. There are our flaps. And I think 5 FPS is fine. Let's turn off looping, so it only flaps when you press the key. And let's now add the collision shape for this. So let's zoom in over here. Let's add a collision shape. Let's use the circle. And you can drag the handle if you like to kind of cover this bird. I'm going to adjust this. I think 14 should just about do it there. Yeah, we can be a bit forgiving on the edges there. All right, so let's just go to our animation. Let's just put it on loop for a second and play it and see what we got there. Yeah, let's just hide that for a second. There you can see our flapping bird. That's great. Okay, turn looping off. Okay, let's add a script to the bird. So let's add a script. It's going to be in the scripts folder. It's called bird. That's fine. Create it. And let's grab our let's remember we said we needed to give it a class name bird. So let's say class underscore name bird. Class name bird extends character body 2D. So now this bird is called a bird. So when we do that test for the bird, it will find it. We're going to need our animated sprite to stop it playing. So let's drag, hold control, and then release. So we've got our on ready for the bird as well. Let's maximize this. We're going to need some constants that we can rely on here. So let's create them. So let's create a constant. Let's call it flap force. And it's a float, and we'll make it equal to minus 400. So that's going upwards by 400 pixels every time we apply flap force. Let's get the max fall speed. So constant max fall speed, also a float, and we can make that equal to 600. And let's have a constant for gravity, pulling us down. It's also a float, and we can set gravity to 900. Then we've got our on variable on ready, so we've got access to our animated sprite. Okay, so let's create a function to apply gravity. So let's say func apply gravity, and we need delta for this one, which is a float, but we won't return anything. And what we'll do is we'll say the velocity in the y direction is plus equals our gravity constant times delta. And if velocity in the y direction becomes greater than our max fall speed, then we set velocity to our max fall speed. So you can't fall faster than 600. Okay, that all seems good. So now what we should do is test that gravity actually works by applying it in the physics process function. So if we go to physics process, we call apply gravity, pass through delta, and remember your last call in the physics or the process function should be move and slide to actually apply the physics. Now if we preview our scene, let's save it, we should see the bird fall. So we should see there the bird falls. And we can actually look at this in the main scene. So let's go to main, let's click on main, click on the little chain to instantiate a child scene, and let's add the bird. And now if we run the main scene, we should see the bird drop. And of course, there's no stop function in the bird yet, so it's going to crash. So now we know that our gravity works. So now we can move on to the next part, which is making the wings flap. Okay, so let's do that. Let's add a function to make the wings flap. So let's say function flap, and let's void. We'll maximize this. And what do we need to do? Well, we need to check if the player is pressing the action keys. So we'll say if input dot is action just pressed flap. Then we play our animation. So animated sprite dot play flap. Then we can move the bird upwards by flap force, and what we should do is when the bird flies upwards, it should tilt upwards as well. So we should change its rotation. So we'll say rotation equals degrees to radian, and let's tilt it up by, say, 30 degrees upwards. Remember, up vertical is negative in Godot, hence the negative 30. Okay, now we can go ahead and test that as well. If we go and call the flap function in our process, then we can test that the flapping works and that the bird tilts upwards when we flap. So let's play our main scene, and there you can see as we flap. Let's just move the bird into the center so that we can see that a bit better. So let's move the bird there. So now it's just so now you can see that as we flap, the bird tilts upwards. Of course, the bird doesn't tilt downwards yet. We're going to do that next, but that is working. Okay, so when the bird falls, it should rotate towards the ground. So rotate almost to 90 degrees to the ground. So let's add that. So let's create a function, and we'll call it rotate while falling, and it'll need delta so we can make a smooth rotation over time, and it won't return anything. So now we'll say if velocity in the y direction is greater than 0, so that means we are moving downwards, then we are going to say rotation equals, and what we're going to use here is a lerp, a linear interpolation, to smoothly rotate the bird, rotate the angle of the bird. So we'll actually lerp the angle. And there's a built-in function called lerp angle, and you can see it says we're lerping from what to what and by how much. From what to what and by how much. Okay, and what we're lerping is the rotation, the current angle. We're lerping it towards 90 degrees, so we'll say degrees to radians 90. And by how much? Well, that's up to us. Let's say 2 times delta. So each time, every frame, we rotate a bit closer to 90 degrees. So now, with that done, we should be able to see the rotation while we fall. So let's call that after flap. Let's call rotate while falling. Save it. We need to send through delta, so let's send that, save it, and we can actually test it. So let's run, and now you can see as we fall, we rotate, we get that smooth rotation. Okay, so this is working very nicely so far. Let's create a death function for the bird, because once you're dead, you shouldn't be able to, once you've hit the ground, you shouldn't still be able to press the flap key and flap up again. So let's add a variable at the top here. Let's add a variable here called let's add a variable called dead. Oh, is dead. Is dead. It's a boolean and it's equal to false. In the beginning, you're definitely not dead. And then what we can do is over here, if you've pressed the flap key, we can say if not is dead, then you can do these things. So you can only fly if you're not dead. So then we should have a function that allows you to die. So let's create a function called die, and all it does is says is dead is true. All right. Now what we can do is we can add the instructions for the game, because we've actually got that. So we can go to our bird over here. We can add a sprite, and we can rename it to instructions, and we can set the texture to the message over here. So if we go to 2D, we set the texture to the message. There it is. And we can, it's covering the bird. So what we can do is under visibility, we can say show behind parent, and we can actually set it to top level so that we can arrange it without affecting any cameras and things like that if we happen to add cameras to this. Actually, I don't know if we need top level right now. We'll leave that off. But let's set the position to the middle of the screen. So let's go transform. Its X position can be 144, and let's move it down on the X, on the Y a little bit, say 200. And there we get the instructions right in the middle, top center of the screen there, which looks great. Now we will need to fade. I want to fade this these instructions away once the player clicks play. So let's get access to it in the script. So if we go to the bird script now, let's go up to our onReady over here and get an onReady for the instructions as well. So now we have access to it as its name is instructions. And in our flap function, once they've pressed the flap key and they're not dead, we can actually fade these instructions away. And the way we'll do it is with a tween. So we'll say we'll create a tween, and a tween is just a programmatic way of animating something that is simple, something quick. And all we're doing is a fade. We're setting the alpha. We're fading those instructions away by changing the alpha channel to 0 over time. So we'll create a tween. So var tween equals create tween, and then we're going to tween a property. So we're going to say tween dot tween property. What is the object we're tweening? It's the instructions. It's instructions. What is the property that we're tweening? Well, it's modulate, and it's not just modulate, it's the alpha channel. So we have to say :A. And then what's the final value going to be? Well, the final value will be invisible, which is 0 on the alpha. And what's the duration? Over how much time should this happen? And we'll do it over half a second. So that will be what we tween. And now what I want to do is once it fades away, we can actually delete these instructions. There's no point having invisible instructions on the screen. Let's just free them. So we can use a callback to do that. We can say tween dot tween callback, and I want to say instructions dot q3. And that should fade the instructions away once we click the flap. The game shouldn't start until the player clicks the button. So to do that, we need a variable now to check whether the game has started or not. So let's add a variable at the top called isGameStarted. And then, yeah, so let's add a variable at the top here. So let's go, we've got dead and alive. Let's go var isGameStarted. It's also a Boolean, and we'll say it's false. The game hasn't started. Then in our flap here, if they've pressed flap, then we'll say if the game has not started, so not is game started, then we'll set is game started to true. So that's the game starting. And then, okay, what we should do is, if the game hasn't started yet, we've got to stop processing things. So in the physics process function here, we apply gravity, we flap the wings, but we need to actually say here, if not is game started. So if the game hasn't started, we should just exit and not try and do anything further. So let's test if that works. Yeah, and there we go. So nothing happens until we click the flap key. And I think we die instantly, so let's just fix that. So if is actually press flap, game started is true. Then I think this can all come back. Yeah, because if the game hasn't started yet, we simply start the game. Then we do a separate check to see if we are dead. Let's test that. So there we go. I think the tweening, sorry, so I've mixed up the order here, but this tweening, yeah, that's part of starting the game. The instructions disappear. Then, if you're not dead, then you can flap. Let's test that. There we go. Yeah, that's better. And now we can fly. I actually noticed another problem, because if you preview the scene, we've got our instructions here, but as we click, they rotate just like the bird rotates. The instructions rotate upwards, and that is why we should enable top level on the instructions. If you go to instructions and you click top level, what it does is it prevents the object from moving with the parents. So because instructions is a child of the bird, it was copying the movements of the bird. But now it won't do that. So now if we preview the scene, you'll see the instructions are here and they don't tilt, they just fade away, whereas the bird can still do its movement as normal. The other thing we can do is we can add the stop function for the bird. So if we go to the bird, after our die function, let's add that stop function in. So let's call it stop. It doesn't return anything, so it's void. And what do we need to do when the bird stops? Well, we can stop the animation. So we can say animated sprite 2D.stop. We can set the velocity to 0 on the y-axis. So we can set that to vector 2.0. We can call the die function, and we can, and this is not y, sorry, this is total velocity, and we can also set gravity to 0. Although gravity we can't change because we made it a constant. So perhaps gravity should be a variable. So let's change this to a var called gravity, and let's just move it to our other variables over here. Let's put it up here. So there's our gravity, and we'll have to change it. I think that's the only place that uses it. And now we can set gravity to 0 as well. So now when we run the game, we have our instructions. When we click, they fade away, and when we crash, everything stops, and you can't fly anymore. Next up is the pipe, or the pipe pairs. The pipes. Okay, so let's make a new scene. Okay, so new scene, and the pipes, they can be area 2Ds. So let's go other node, and let's add an area 2D, create. Okay, so this is where we're going to put our pipes. So let's rename this scene to pipes. And actually, let's have this as a, let's change the type. This can just be a node 2D. Okay, called pipes. And then as a child, we'll add an area 2D. And this can be the top pipe, because you're going to have a pair of pipes, a top and a bottom pipe. Let's add a sprite 2D as a child. And let's add a collision shape as a child. And then let's duplicate this top pipe node, so Control D, and rename this to bottom pipe. So now I've got a top pipe and a bottom pipe. Great. So now let's select the top pipe, and let's add a texture. Well, let's go sprite 2D. Let's find that green pipe. So here's pipe green, and let's add that texture there. There's our sprite. Okay. And let's rotate it. This is the top pipe, so it should be upside down. So let's go to the transform, and let's set the rotation to 180. So we've now got this as the top pipe. And let's grab the collision shape. So let's set the collision shape. Let's add a new rectangle. Okay, and we can resize it. This just to fit the pipe. There we go. Make sure we get the bottom here. Okay. And then let's select the bottom pipe. Okay, let's set the give it the same texture here. Let's give it that one. Okay, and let's get its collision shape. Also a rectangle. Let's resize it. And that looks okay. Now we need that gap between the pipes. So let's click on the top pipe and let's set its position to, since this is the top, let's set the Y to -150. Let's now go to the bottom pipe and let's set its Y position to 300. Okay, so now we've got that gap between our pipes. Okay, now let's go and select the root node and let's add, okay, when does the player score? Well, the player scores once they move through the gap between the pipes. So the gap, once they pass these pipes, that's the scoring area. So let's add a scoring area. So let's add another area 2D. Let's call it scoring area or score area. And let's add we obviously need a collision shape for it. So let's add that. It can be another rectangle. Okay. And let's kind of resize it a bit. Let's get the gap between the pipes there. Yeah, and let's move this score area past the pipes. So then they know they've scored if they make it past the pipes. We can actually make this a bit like this, just to make sure that they definitely cross through that scoring area. So if they pass through that, they've scored a point. Now, you know, when the pipes move off screen, we should delete them from memory. So Godot actually has a nice way for us to do this. We can click on our root node here, and we can actually search for a node called here, visible on screen notifier. Okay, this will notify us when something is no longer visible on the screen, and then we can just delete it, Q3. So add that. Here it is, visible on screen notifier 2D. So let's, we'll connect its signal in a second. We need a script to connect the signal to. So let's first add a script here to the pipes. Okay, so let's save our scene as pipes. Save. Okay, click on your root node, add a script. Pipes is fine. Let's make sure we're in the scripts folder and click create. Let's give it a class name. So we'll say class name pipes. That's perfect. And let's now go ahead and let's go full screen here, and let's add in some variables. Okay, so the speed at which the pipes move past, that can be an export variable. I'm happy, you know, with that, but let's just set it to 0 for the moment. Okay, so we can actually create a function to set that speed, because we might want to increase the speed depending on how far in the game the player is, and how well they're doing, etc. So let's create a function called set speed, and we can receive a new speed, which will be a float, And all it's doing really is setting the speed, so it's not returning anything. And we'll just say speed equals new speed. Now, in the we can move the pipes just by multiplying speed by delta. So, or in fact, we'd have to change their position. So let's say function process, and we can just say that the x position of the pipes is equal to speed times delta. That should move the pipes. Then we need to score a point. What we can do to score a point is select the score area, find the body entered signal and connect it. And all we have to do in the body entered signal is check if the body is a bird. So we can say if body.name equals bird. And if it is a bird, then we can go to our signal bus and add a point. We can add a point. And that is how we score points. So in a similar way, what we can do is when the bird hits a pipe, we can call the signal bus's crashed method. So if we go to the top pipe over here and we go to its body entered function here and connect it, we've got here function on top pipe body entered. What we should do here is say if the body dot name equals bird, then we're going to go to our signal bus and call bird crashed. So we're going to emit bird crashed dot emit because the bird has crashed. And what we can do is just connect the bottom pipe to this same function. So we go to the body entered, pick it, and we'll go on top pipe body entered and we'll connect to it. So if you hit either pipe, it's going to emit the crashed signal. And if you enter the score area, it's going to emit the add point function. Or it's going to call the add point function that we made. Okay, that should work. What we still need to do is when the pipes go off screen, we actually need to delete them. So if you click on the visible on screen notifier and you go to screen exited and you connect it, all we have to do is go queue free. And it will delete the pipes when they go off screen. Now we're just hoping this is all going to work correctly. We should really test this. But we can't actually test this because we've got no way to spawn pipes at the moment. Alright, now we have the pipes. Now we need something to spawn these pipes because this is all code for a single pair of pipes, and all it does is set the speed of the pipes, move the pipes, and score a point or crash into the pipes or delete them when the pipes are no longer on the screen. So I want to create a helper class to spawn the pipes. I'm going to call it my pipe spawner. Let's create a new scene and we'll just have a generic node as the root. Okay, and we'll rename it to pipe spawner. And we'll actually add a timer node to help us spawn pipes regularly. And we can rename this to spawn timer. And let's now attach a script to our pipe spawner. So add a script, make sure you're in the scripts folder. Pipe spawn is fine, create it. Let's give it a class name, so we'll say class name pipe spawner, extends the node, and we'll create a variable here called pipes, and it'll be a packed scene, and we'll preload our pipe scene. So if we come down here to our scenes, we've got our pipes. I'm just going to drag it and release it in there. That's our pipe scene, preloaded, ready to go. Then we can create some export variables. So we can say export var pipe speed. It'll be an int. We can set it to -150, and we can actually create an export range going from 0.0 to 1.0, and we'll say var spawn margin top. So we have float, and we'll set it to 0.15. And what you'll see is we get this bar that we can drag, and this will increase the distance between the two pipes. Okay, and by default it's 0.15, and we can actually do this again. So we can say export range going from 0.0 to 1.0. We'll call it bar, and this will be the spawn margin bottom, and it'll be a float, and we can set this one to 0.65. And this is for our gap. Okay, and now we actually need the spawn timer as a ready variable. So let's grab it. Now we have access to it. Okay, and now we can create a function to spawn the pipes. So they spawn as a pair, but we'll call it spawn pipe. So function spawn pipe, and it just spawns the pipe. So we'll say var pipe is going to be equal to pipes dot instantiate, and then we'll add the pipe to the scene tree. So we add the pipe. Now we need to work out the size of the viewport, the size of the screen, so that we can position the pipe at the right edge of the screen, which will be the maximum width of the screen. So we can say var viewport size, and we can make it equal to get viewport dot get what's it, visible rect dot size, and then we can position the pipe at the edge of the screen. So let's just say here position pipe at right edge. So we can say pipe dot position dot x is going to be equal to viewport size dot x. And then for the y, we'll use those margins that we set up. So we can say the minimum y position is going to be equal to the viewport size dot y multiplied by our spawn margin top, and our max y is going to be the viewport size dot y times our spawn margin bottom. So that's the gap that we have to play with between the pipes. And now we can just say pipe dot set speed to -150. and that should set the pipes moving. Now when we want to stop the pipes, we need a function to stop it. So let's say function stop, and let's say void, and we need to stop the spawn timer. So spawn timer dot stop, and we'll say for pipe in, and we need to get all the children that have been created, all the pipes, and we'll say if the pipe is pipes, then we're going to say pipe dot set speed to 0. So we just stop the pipes moving. Finally, we need to start spawning pipes. So let's create a function to do that. So we'll say function start spawning pipes, and it is void as well. And basically all we need to do is start the spawn timer. So we'll say spawn timer dot start. Now, as far as that spawn timer goes, let's connect its timeout signal. So if you select the spawn timer, if you go to the timeout signal and you double click it, we are going to pick the spawn pipes function. Just remember to save before you do this, or it won't find anything. So now go to the timeout function, pick, we want to start spawning pipes. Actually, we want to spawn pipe. Okay, we want to spawn a pipe each time the timer times out. So we click OK, we click connect. So each time the timer times out, it's going to spawn a pipe and set the speed and set its position and do everything. Now let's test if this works, because we now need to instantiate or instance the spawn timer in the main scene. So let's go to our main scene, click on the instance, choose this pipe spawner and test it. Let's run it and see what happens. So when I click, should get some pipes spawning. Nothing. Okay. There was a small problem. I said position.x equals speed times delta in the pipes scene, in the pipes script. But of course this should be position.x plus equals speed times delta. The other thing we need to do is in the spawn timer, you have to auto start the timer here. Set it to start, because if you don't and you run it, actually I think it will start. No, you have to turn auto start on. So in the pipe spawner, go to the spawn timer, set auto start to on, and this time here is the time between spawns. So if you want them to spawn more spread out, you can increase that time. Yeah, maybe you make it 2 seconds, and then we get a bit more distance between the pipes. Yeah, that's a bit better. Yeah, I would go with 2 seconds, because 1 second is a bit tricky. Maybe even 1.8 or something like that. Anyway, but our game is coming together here. It's coming together very nicely. All right, so let's see. It didn't look like the ground was scrolling anymore. Oh, that's because we crashed and we stopped the ground. Okay, yes, I wasn't playing very well. Okay, so we now have the pipes moving, the bird flapping, the ground going, the instructions, the game started. When we crash, let's add a little fade effect so that you can see that you've crashed and the game's about to restart. So let's create a helper node to do this. So let's create a new scene. Again, let's just use a node as the root here. And let's rename it to fade. And let's add a color rect as a child and an animation player. Animation player. And there we go. Now, let's go to 2D over here. Let's set the, let's choose the animation player. Let's make a new animation and let's call it fade. And let's set the duration to 0.25 seconds. 0.25. Let's zoom in here. Okay. Let's click on the plus to add a track. We're going to add a property track. We're going to choose the color rect. We're going to say OK, and we're going to choose the color property. We're going to open that. Right now, at 0, 0 on the timeline, right where we are at the beginning here, let's insert a key. So right click, insert key, click on it. Okay, click on that, turn alpha off completely. Okay, alpha off at the start. Okay, at 0.2 seconds, so let's change to 0.2 seconds. Let's insert another key. Or actually, wait. At 0.1 second, sorry, let's 0.1 second, right? Let's insert a key. Click on it, and let's turn alpha on. Oh, and we should set the color. It doesn't matter on this one because alpha's off, but the color should be black. So, because we want to do a black fade, let's just set the color to black. Then let's move to 0.2 seconds. Insert a key. Okay, click on it and put alpha off again. Okay, so we have a fade effect. If you zoom, you get that. Now we don't want this tiny little rectangle, so click on color rect and let's go to the anchors and choose full screen. And now we play our animation again, you get this little black fade. Okay, which is fine. So let's add a script to the fade node. Let's go to fade, add a script, make sure we're in our scripts folder, click create. We can give it a class name, so class name fade effect extends our node. Let's grab the animation player as a ready. Okay, so drag it across, hold control as you release. Let's create the ready function. And all we need to do is play the fade effect. So animation player dot play fade. Okay, and it should play the fade animation. Now, when the animation's finished, we can delete it because there's no reason to keep it. So let's go to the animation player, go to node, select the animation player. Let's just, save the script, save the scene. Okay, go to the animation player, find its signals, and let's find the animation finished is what we want. Animation finished. There it is, animation finished. Okay, let's double click that, click connect, and all we want to do is when the animation is finished is we want to queue free, delete it. And now we can instance the fade effect in the main scene. So if we go to the main scene and click on it and we click instance, we can choose fade. And now we have a fade effect which will play as soon as it becomes ready. So, and we'll make more use of this when we crash. So now what we need to create is the user interface. We need our scores and so on. So let's do that. Okay, so let's create a new scene. Let's go other node, search for something called a canvas layer. Okay, click create. So now this canvas layer is a special node. It creates a separate rendering layer on top of the game world. So it's independent. Nodes that you put inside a canvas layer, they ignore any camera that you have. They don't move when that camera moves. They have fixed coordinates. They're always fixed at 0, 0, so that the top left corner of the screen, regardless of where the player is in the level, and it's always on top by default. A canvas layer draws on top of everything else: sprites, tile maps, backgrounds, everything. So let's save space for the score. So let's add a margin container. So there's a margin container. And let's set the top margin to 32. So if you go to layout, not transform, container sizing. No, where is the margin? It's in constants, I think. Yeah, so margin top, let's set it to 32. 32. Okay, so we've got a top margin of 32 pixels. Let's set the size of our container to our screen size. So if you go to, here's our minimum size. Our screen size is 288 by 512. And we can set the anchor to full rect. So we can go to full rect. And let's add an HBox container as a child of the margin. So this is to align everything horizontally. This will be for the points. So let's click on that. Let's search for HBox, so horizontal box container. Let's rename this to the points container. This is where the points are going to go. So points container. Let's set the alignment to center. So it's going to be, points will be in the middle of the screen, horizontally. Then let's add a VBox container as a child of this margin. So let's add a VBox container. And this is for the game over box. So let's call this game over box. Let's set its vertical sizing to shrink the center. So let's find container sizing. Container sizing, out, container sizing. So horizontally we can leave on fill, but vertical will shrink to the center. And stretch ratio we can leave as 1. Let's now add a texture rect for this as a child. So let's go, we've already used this, so it should be, no, we used color rect. Okay, so let's search for texture rect. There it is, texture rect, create. And let's set its texture to the game over texture that we've got, which is somewhere here. There, game over. That will be the texture, game over. Okay. Now, as a child of the game over box, let's set the let's add a panel as a child. So let's add a panel, create that, and let's set the size to 200 by 100. So that will be the custom minimum size. Let's go 200 by 100. Okay, so we've got nice space there for it. And let's add a text direct as a child of this panel. So let's add a text direct. And this will be the medals that you get. So let's add the medal frame as the texture for this. So let's just look for medal frame. There it is, medal frame. Let's add that. So that's our medal frame over there. And let's set the stretch mode to keep the aspect. And let's set the position to 40. So we move it to the center a bit. So that's our transform. Our X position, we'll move it over to 40. And let's set the layout mode to anchors, and let's set the anchor to full rect as well, so it takes up that panel. And then let's set the we have to do the X position again, so it's more centered. There we go. I like that. All right, now we've got here a score. That's the round score, and then we've got best. That's the best score. So let's add some containers to house those scores over there. So let's add two HBox containers. Okay, as a child of this panel. So let's add another HBox container, and let's call this one round score. So let's say round score container. And then let's add another one, and let's call this one high score. This is going to be, or best score, best score container. Okay, let's set the alignment to center for both of these. So alignment can be center. And for the round score, okay, we want it underneath that word score, so we could actually just drag it there and drag this down and resize it, something like that. For the best score, we also want it to be there, down, and resized, something like that. Okay, now I want a button to appear in the middle here that lets them restart the game. So let's add a button to this panel. So we're at the panel, add a node, let's search for button. There it is, click on create. Okay, let's set the text to restart. And let's change the font. Since we've got a Flappy Bird font, let's use it. So if we go down to theme overrides, fonts, we can go to quick load, and it'll find the only font in our project, which is Flappy Bird. Click on that. Now we've got the Flappy Bird font text. Let's change the size to about 32. So let's go here and say 32. And let's move this sort of to the middle. So let's move it across like that. and move it down. So they click restart over somewhere there. That looks good. Okay, so they're going to hit restart. Now, depending on their score, they're going to get a medal over here. So let's work on those medals now. So let's add a texture rect again as a child of this panel. Texture rect, create. Okay. Let's rename this to metal texture, just because we've got another texture rect up there. So we'll say metal texture. And now let's set the default one to the bronze. So I'm going to drag this in. There's our bronze medal. And let's just move it over the impression, in the panel. So let's move it somewhere here, just so it fits just a little bit. That looks pretty good. And let's turn its visibility off, so we'll only make it appear when you get a medal. Okay, so I've turned the eye, closed the eye. Right, that's setting up the game over screen. So now let's actually add a script to our canvas layer. Let's rename this canvas layer to UI, so we know this is the UI. So UI, and let's save this scene as UI.scene. Save. Now we can add our script. So add. Here we're in the scripts folder, and click create. Now we're doing the script for the canvas layer. Okay, so let's give it a class name. Let's call it UI. So we'll say class name UI extends canvas layer. Now let's get references to all of our different containers. Okay, so I'll say here references to containers. So what do we need? We need the points container, which is here. We need the game over box, which is there. We need the round score. We need the best score. We need the medal texture. I think that's all of them for now. Now, this is the interesting bit. Because we have textures here for each of the digits. So 0, 1, 2, 3. These are sprites. These are PNGs. These are images. We are going to have to convert the score into a string, loop through each character in the string, and replace each character with the image of the score. So what we should do is preload all these digit textures so that we're ready to use them when they are needed. So let's say here, let's make a little note for ourselves. Preload all the digit textures. Okay, so we'll just store them all in an array. Let's call an array here. Let's call it digit textures. Is an array of texture 2D. Okay, and they're equal to, and we'll open our array. And now we can say preload, and now we can just grab them one by one. So 0 is there. That's 0, and then comma. Preload, and now 1 there. Comma, and we'll have to do this again and again, so let's just copy and paste. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9. Okay, those are all our digit textures. Oh, no comma on the last one. Okay, those are all the digit textures. Okay, they're ready to be used. Now we've also got textures for all the medals, because we've got the bronze, the gold, the platinum, and the silver. So let's preload those to be used as well. So let's say preload medal textures. Okay, so we can say var medal textures again is an array of texture 2D, and it's equal to, and we're going to say preload, and we want to grab the bronze, comma, and preload, we grab the silver. Oh, I just realized you can hold control and drag and get a preload. Let's do that instead. So if you hold control and drag, we'll get a, okay, no, I don't know how I did it now, but I saw that it automatically did the preload for me. This is the gold, and we need the platinum. So okay, so we have our medals ready to go as well. Okay, so the next thing we're going to need is a way to update the points. And we've got points in two places because we've got the current round score over there and the current best score over there. So the round score is in its own container and the best score is in its own container. So we're going to need to make a function that will accept a number, you know, the points that have been scored, and a container. Both of these are HBox containers. So we can accept an HBox container, and then we update each one based on the score. So let's go and do that. So let's create a function. Let's call it set container score, and it'll receive a score, which is an int, and it'll receive a container, which is an HBox container. And it doesn't return anything, so it's void. Colon. Right. So the first thing we should do is, if there were any digits there from a previous round, we should clear those away. So let's make a little comment here for ourselves. Clear old or previous digits. So we just need to go through the containers children and Q3. We'll say for child in get, it'll be in the container dot get children, and we'll just Q3, so child dot Q3. Okay, so that deals with clearing away any previous scores. Now we should convert the current score to a string, because we need to each character has to be replaced with one of our digit textures. So let's make another note for ourselves here. Convert the number to a string. Convert score to string. So we'll say that var score string is going to be equal to the string version of the score. Okay, so now we have the score as a string. Now we should create the texture for each character. So let's make a note for ourselves here. Let's say create a texture for each digit character. So we'll say for digit char in score string, we'll say var digit as an integer is equal to the int version of the character. And then we can go and grab the texture. So we'll say var texture rect is a new texture rect. We could make it a sprite, that would work too. We'll just use texture rect dot new, and we'll say texture rect dot texture will be equal to our digit textures, and because they're named 0.png, 1.png, 2.png, etc., we can match them to our digit int. And now we can say texture rect dot stretch mode, just so that it doesn't stretch them, will be digit texture rect stretch keep. So we just keep the aspect ratio of those images. And now we can add that texture to the container. So we say add child texture rect. Alright, so this little helper function accepts a score, accepts a container, deletes whatever's there, converts the score to a string. For each character in the string, converts it into an image, and then puts the image in the box, in the container, the H box. Alright, so now we can use this to update the score while we're playing. So let's create a function called update gameplay score, and it will receive some points. They're an integer. The function doesn't return anything, and we'll use our set container score function, and we'll send through points. And the container we want to update for this function is the points container. Points container. Because if we go out and we look at the points container, it's that one there. So in 2D, our points container is the V box. That's the H box container. Which one is the points container? It's this entire container here that we're updating. So yeah, that seems correct. Okay, what do we need? We need now a function to assign the correct medal, because you get a different medal based on how many points you got. I think it was 40 for platinum, 30 for gold, 20 for silver, 10 for bronze. So let's do a function to assign medals. Okay, so function assign medal based on the score, which is an int, and it's void. So basically, first off, whatever texture was there, we should just make sure that we reset it, we make it invisible again. So let's say medal texture dot visible equals false. Then we can check our thresholds. So we're going to say if the score is greater than equal to 40, then our medal texture dot texture will be equal to medal textures. This is platinum, so which one? 0, 1, 2, 3. Metal textures 3. And now we can make it visible. So metal texture dot visible equals true. Now we're going to repeat this a few times. Let's copy this and paste it here, and this becomes LF score. And this one is now 30 for gold, so that is 2, and 20 for silver, so that is 1, and 10 for bronze, so that is 0. Okay, and that is platinum, gold, silver, and bronze. That's the medals. Now we need a game over function, which will display the game over box, set the round score, set the best score, and assign the medal. So let's do that. Function, let's call it on game over, and it's void, and we're going to say make the game over box visible. So visible equals true, and that means we should make the game over box here invisible to start. So just click the eye closed. So now it's visible. Now we should display the round scores. So let's say show round score. Okay, so we're going to use our set container function, set container score. We're going to get the score from the signal bus. We're going to say signal bus dot score. That's the round score. And which container do we want to update? This one, round score container. So we're going to say round score container, because we already gave ourselves a reference to it up there. Right, so that's the round score. Now we should show the best score. So let's show best score. Yeah, full screen that again. So now we want to show the best score. So the best score, again, we're going to use our set container function. We're going to go to the signal bus, and we're going to get the high score, and then we're going to update the best score container. Then we need to assign a medal. So we can say assign medal, and we need to get the score again from the signal bus. And then I think that's all we need to do for the scores. Let's just get rid of these spaces here. Yeah, so we make the game over box visible. We show the round score and put it in the right container. We show the best score and put it in the right container, and then we assign a medal based on the score. That sounds perfect. All right, now for the reset button, let's just show the game over box again. This button over here, the reset button, when they click this, it should restart the round. So let's select the button, find the pressed signal over here, and connect it. And let's replace it. All we need to do is say get tree dot reload current scene, and it'll just restart the current scene. That looks good. I think now we need to use the ready function, because we actually need to connect the signal bus score updated function to our update gameplay score function so that they are communicating with each other. And then we should clear the score at the start of the game and set that game over box to invisible when each time the game starts. So let's create the ready function underscore ready. Let's connect the signal bus's score updated function. We go back to our signal bus. It's got a function. It's got a signal, sorry, here to update the score that receives a score. So let's connect to this. Let's connect this signal to our gameplay score, which also is the same signature. It also receives the score. Okay, so let's do that. So we're going to say signal bus dot score updated. So that's the signal, and we're going to connect it. So we're going to say dot connect, and what are we going to connect it to? We're going to connect it to our update gameplay score. Okay, so when this signal is emitted, it runs this function. Perfect. Now let's clear everything at the start. So let's just say make a fresh start each round. Okay, so we're going to say our set container score. We're going to set it to 0, and we're going to update the points container. And then we're going to say game over box dot visible equals false. So it goes back to invisible. Now, do we need anything else in the user interface? Personally, I think that's it. So let's save this. Now, what we actually need is a game manager. Something that is going to be responsible for the game loop. You know, it should handle setting up the game when the scene loads, resetting the scores, connecting the signals. It should handle deciding when the game starts, ends, pauses, or restarts. It should also tell all the other systems what to do. So it should tell the spawner to start spawning pipes, or it should tell the user interface to show the game over box. So let's create a game manager now to tie everything together. So let's create a new scene, or in fact, let's just go to our main scene, and in our main scene, let's add a node, and we can just have an empty node here. Let's create that. Let's rename this node to Game Manager. And let's move it to the top. And now let's add a script to it. So click Add Script. Let's put it in our scripts folder. Create. Right, and let's now add some references to what do we need? The bird, the pipe spawner, the scrolling ground, the fade, the user interface, all these things. So let's grab the bird. Let's grab the pipe spawner. Let's grab the fade. We don't have the user interface, so let's instance that and grab a reference to it as well. So what else do we need? We've got the bird, the pipe spawner, fade. Oh, we could use the scrolling ground. Let's grab that. All right, what we need now in our game manager is a way to start the game and a way to end the game. So let's create a function called onGameStarted. And all we have to do to start the game is tell the pipe spawner to start spawning pipes. So pipe spawner dot start spawning pipes. That's the easiest way to start the game. Now, to end the game, we need a function. So let's create a function called endGame. And if the fade is not playing, then we'll play it. So if fade is not equal to null, then fade.play. And then we should stop everything. The scrolling ground, the bird, the pipe spawner. We should just stop them. So let's say scrolling ground stop. Bird dot die. Pipe spawner dot stop. We should check if this round's score is the high score. So let's go to the signal bus and call check high score. And then we should call the user interfaces on game over method. Okay, those are the two main things the game manager has to do: start the game and end the game. In the ready function, so when the game manager loads, we should reset the score. So we'll connect to our signal bus and call the reset score method. And we should now connect our two signals in the signal bus, game started and bird crashed. Game started should connect to on game started, and bird crashed should connect to end game. So let's say signal bus dot game started dot connect. And what are we connecting to? We're connecting to on game started. And our other signal is bird crashed, so bird crashed, and we'll connect that to end game. Right. That should give us a working game. Let's play and see. Okay, so there we go. All right, the pipes should not have started spawning. We'll investigate that, but that only disappears when you click. We are passing through. I don't like the distance of the pipes. Let's just check that. So if we go to our pipe scene, or it's the pipe spawner actually, it's this our margin at the top. I'm going to make the top margin much smaller and maybe make this 0.5, really tight margins. Let's have a look now. Now if we run, yeah, that's much easier to play. Okay, and there we're getting our score and our best score. And let's just see, so 2 is my best score so far, and it's still registering the best. Yeah, there's 2, almost. Okay, even if I restart the game now, if I close it and restart it, because we saved that best score to a file, it should still have our best. Even if I crash now, still got our best as 2. Okay, so let's just try again. I'm really bad at this. Come on. It's better. Ah! Okay, no, I can't handle this. Let's now add the audio. That's the last step to finish this off. Okay, because we've got a whole audio folder. If we look here, we've got the die, the hit, the point, the swoosh, and the wing flap sounds. So let's use those. So the easiest way to do this is to create a new scene. Just have a node, basic node again, because this is not going to be visible. Let's call it the Audio Manager, and then we're going to add 5 audio listeners. Let's add 5 audio stream players, just this basic one. So we're going to create it. There it is, and I'm going to Control D 4 times. Okay, so we've got 5 of these players. Now we'll just name them after each effect. So we've got the swoosh player, and in the swoosh player, in the stream over here, I'm going to add swoosh. Then the next one is our die player, and I'm going to add die to the stream. The next one is our wing player. I'm going to add wing to the stream. The next one is our point player, and I'm going to add point to the stream. And the final one is the hit player, and I'm going to add hit to the stream. Now we have all our sound effects. Now we can add a script to this audio manager. Let's add a script. Let's just make sure it's in scripts. Great. Here's our audio manager, and we need references to all the players now. So let's create those. So drag, control, release, drag, control, release. Get our references. Okay, now we have our references. Now let's create a function to play the wing sound. So function play wing, and or does it say wing player dot play. Okay, let's create a function to play the points sound, but only if the score has changed. So, you know, because we will change the score back to 0 every time the round restarts, and you don't want to play the point sound when the points are 0, have changed to 0, only when they've gone beyond 0. So function play point, and we need to know the score. So there we go. And if the score, and in fact score here is only used by this function, so you can put an underscore there. If that score is 0, then we leave the method, we don't play the sound. But otherwise we're going to say point player dot play. That will play the points. Now for crashing into the pole, we got 2 sounds to play. So let's work that out. So function, it's our crash sequence. Let's call it play crash sequence. Okay, so what happens is when you crash into the pipe, it plays the player hit sound and it plays the swoosh sound to kind of restart the level. Those sounds could play at the same time. We don't, if one of them is already playing, we don't want to play our crash sequence sounds. We want to leave the function. So if the hit player dot playing or die player is playing, then we're going to leave. We're not going to play another sound. I don't want to play sounds over each other. Otherwise, first we play the crash sound. So we're going to say hit player dot play. Then we're going to wait a moment. So we'll create an inline timer here, and we'll say wait, then play die sound. Okay, so we're going to say, we'll make an inline timer. So we'll say await get tree dot create timer. How long do we want the timer to run for? Let's just say 0.3 seconds, and we wait until it times out. And when it times out, that's when we play die player dot play. That should work. Okay, what else do we need? Ready. So what we should do in the ready function is connect to our global signals. So we'll say function underscore ready, and we'll go to the signal bus, and we'll go to the game started, so dot game started, and we'll connect that to playing the swoosh. Play. Have we got a swoosh yet? We didn't make the play swoosh. Because when the game starts, it should play that swoosh sound. So let's add that just under here, under play wing. We may as well put it up there. So let's have function play swoosh void, and we'll say swoosh player dot play. There we go. Come back to our ready. So now we can connect this to play swoosh. What other signals do we have? Well, when we score a point, so signal bus dot score updated, and we need to connect that to play point. So when we update the score, we also play the point sound. And the last one is when we crash the bird, then we should play the crash sequence. So signal bus dot bird crashed dot connect to crash sequence, play crash sequence. Do we need anything else? Yes, because we don't have the wing sound, but the playing the wing sound, that is played when you press the action key, so that's going to have to be in the bird. The other thing we need is this audio manager needs to be globally accessible, just like the signal bus was. So we need to make it a global. So if we go to project settings, globals, we search for it here on the path folder. We go to our scenes. Yeah, let's actually save it first because it is a scene. So let's just save it in our scenes folder as Audio Manager, save. Now we go to project settings. We browse for it in scenes. There's the Audio Manager, open it, and then you click add. And now we have the Audio Manager globally available as well. Okay, so we can access it from anywhere, because we are going to need to access it from anywhere, because the bird has to play the flap sound when it presses the action key, when it flaps its wings. So if we go to the bird and go to the flap method, which is here, flap, we want to say, I just realized we left something out here actually. That is why the pipes are still moving when we play the game, because we've said here if the game isn't started, set game started to true, but we haven't emitted the signal bus game started signal here. We should do that. Well, that was a good spot. So we say signal bus dot game started dot emit, so it knows the game has now started. Right, now we were creating the flap sound, so we need to play the flap sound we can just do that as the last call in this function over here. We may as well make a little note, play wing sound. So we just say we can connect to the audio manager. Audio manager, there it is, audio manager dot play wing. Save it. All right, let's test it. We should have audio in our game now as well. So play. There we go. Restart. Let's see if I can beat that high score of 2. And let me just check that it works with the spacebar. Yes. I will do it, guys. I will do it. Yes. Okay, 6. Not bad. Well, I hope you enjoyed the tutorial. I hope you learned a lot. If you did, please like, comment, and share. It really helps me out. Tell me what tutorial, what foundational project you'd like to see next. I'm thinking maybe Snake. Anyway, I hope I helped someone out there. See you next time.